Hello, this is Bruce Barclay coming to you from J-Tech Automotive Technology School. And today we're going to talk about, we're going to get real in-depth with the cylinder head here. Um, First of all, I'd like to tell you that if you're going to remove a cylinder head from a vehicle, you need to do a lot of inspections on that vehicle to make sure that when you remove the cylinder head, you're going to find the problem that the customer has. In this case, our customer had an engine that was suffering from a condition called hydrolock. And what hydrolock is when water enters the combustion chamber from the cooling system and fills it up to the point where the piston cannot move anymore. You can't compress water or fluid, so what happens is the piston will not move, and the engine, when you go to turn it over, the starter will engage the flywheel, but it won't spin the motor. And that means that the engine's just locked up because there's fluid all in there. But there are many, many other reasons why you would need to remove a head from a car in order for you to pinpoint engine running problems. Some of those reasons could be you could have a misfire. Well, a misfire could be caused by a fuel-related issue or a valve-related issue. So you may end up having to find a broken valve. You can use a scan tool to help you figure out whether or not you gotta take the head off or not. But once you've determined that you need to remove the head, the problem for the customer's vehicle is in the head, then you gotta get serious because it's gonna take a lot of man-hours to work on it. And but anyway, we have already removed the head from the vehicle. And the first thing you want to do when you go to do that is check with the manufacturer's instructions. They have particular order for the most part, the order in which you remove the bolts to get the head off of the vehicle. So you want to make sure that you follow those to the letter. If you don't, then you could warp the head. In many cases, they want you to start with the bolts on the outside and then the bolts on the inside and loosen them and then take it off. But like I said, we've already got the head off the motor and we've already done one inspection. I want to show you what that inspection is. Basically what we've done is we've taken a dial indicator and we've placed it on here when it was all rigged up, and we pushed on this camshaft and we measured the camshaft end play on both of our camshafts. And what that result yielded to us was that we had 0.003 thousandths of an inch of end play in this shaft, and we had 0.003 on this one as well. So that being said, we're going to use those numbers and compare them to our specifications from our repair manual, and then we're going to know if that makes our camshafts okay. The next inspection we're going to do is we're going to take out our shafts. And we're going to measure we are going to measure valve stem tip height. And this is how you do that. You need a T-square, machinist scale type T-square, and then you're going to measure from the bottom of your camshaft journal to the top of your valve, and you're going to do that by doing this. You want to make sure that this straight edge is perfectly straight on the bottom of the journal, and then you loosen this little thumb screw up and you drop it down to the tip of the valve, make sure your valve is all up, all the way up, and that your square, you lock it in, and then the distance from here to here is our measurement. And I am seeing 5/16 of an inch. Okay, so I'm going to record that. I'm going to write that down, and then I'm going to measure the rest of my valves. And I'm going to, after I get through doing all the measuring, I'm going to compare that to my specifications, and then I'll know whether or not I've got the proper valve stem tip height. So there we have it. Thank you for watching this segment of the video. Hey, this is Bruce Barkley coming to you again from JTech Automotive, and we're in the middle of doing our inspection on our cylinder head. We have removed all the valves, and we have started to do measurements on some things. First of all, I want to say that this is an aluminum head. It's made by Ford. Its casting number is 107LH, which means it's a left-handed, it goes on the left side of your engine. And it has 3 cylinders, which when we've got 4 valves per cylinder, so that means you got 12. So there you go. We've cleaned it. We have removed all the valves, and cleaned everything. And then we've done our spring height measurements. All these springs have been measured, and this is basically what how you measure them. You want the spring to be on a level surface, and then you're going to use a scale like this, this 90-degree scale, and you're going to put it down here on a level surface, and then you're going to run it across there and see where you're at. Right now we're seeing a bit of a gap in there, so I can drop that down, hit that like that. Okay, now this is going to tell me my spring height. It's letting me know that it's square because it's in line here. I don't see no visible space in there, so I know I got square. And my measurement is 2 1/4. So I got 2.2. It's 2 1/4 inches high. That's how high the spring is. That's how we measure spring height and spring squareness. And then we measured our valves. We measured them here with a micrometer and here with a micrometer. And the reason for doing that is you're checking to see how much wear there is where the valve meets the valve guides. And you're going to compare that measurement to this measurement and see if they're within your specifications to reuse it or trash it. Well, that's where we're at with this inspection process. Okay, here's another measurement that we can do on our cylinder head. What this measurement is called is guide wear. And basically what you're doing with this is you're trying to figure out the amount of wear in between the valve guide, which is my fingers, and the valve here. So the way you do that is you set up a dial indicator and open up one of your valves like so, and then you want to push the valve one way to zero out your gauge, because I'm at one limit here, and then I'm gonna pull the valve the other way, and then when it stops, I want to count how many I got, and I'm looking at 13, 12, so it's 0.00 or .0012 is what our measurement is for that particular valve. This is an intake valve. It's in position number 1, and the wear on it is .0012. Okay, and we're going to repeat this for all the intake valves, all the exhaust valves, and then we're going to compare our measurements against the specifications. Once again, let me show you how we rig this. We've got our dial indicator rigged here, and you basically push the valve towards the indicator and zero out your gauge, which we've got, and then you want to let the valve go and then pull it with just slight finger pressure the opposite way of, or away from the gauge, and then write your recording down, and that's how you do this measurement. Thank you. Okay, now we're going to measure our cylinder head for straightness across the face of it. We're checking this to make sure that it's perfectly level so that it mates up against our block. The way we do that is we use a straight edge and we measure it seven different ways. We take a measurement there, measure it there, measure it in the middle, measure it this way, measure it like this, and then you want to measure it here like this, and here like this. Okay, that's the 7 different directions. The other thing is you have to use your manufacturer's specifications to tell you your limitation on this. And your procedure is, we're going to measure this actually, we're going to measure it this way. And for this particular engine, they want the measurement to be .015. So we're going to run our gauge down along this thing, along the head like that, and try to push that gauge underneath it. And it's only snagging up on me when I get near an opening. It's not wanting to go under it at all. So that measurement's good. And you just repeat that for all the other different directions. And if you find any of them are out of tolerance, what you'll do is you'll send it out to have it flattened out by a machine shop. And stay tuned for our next measurement.